Alright, I have a magnet generator going into the coaxial transformer. This is the direct current input of the generator. I'm open circuit now with the scope hooked up. Open circuit, no load. Okay. It's taken 1.78. Okay. This is our open circuit voltage, 4.59 volts, 4.6, 1.78, 1.79, 1.78. Okay, now let's close the circuit on an 8 ohm resistor. Ready? And go. 1.76, 2.82 volts going through the resistor input on a mechanical generator. Lowers when I take a load. 1760. Unhook it. Back up to 1780s, 1790s. Hook it up. (1760, 1770). Unhook it. Open circuit. Now we're talking not much amperage at all, 0.02 amps at 22 volts. So a little bit of power, but not much. And again, we're not really making a lot of power with this setup. My coaxial transformer is very loose. It doesn't have a lot of turns, which it could. So I'll see if this could be improved, but either way, interesting that we're talking air core. Now everyone's seen reduction of input power with cord transformers, but we're sending the output of the generator through an air core coaxial transformer. Open circuit, 1780, 1785, 1790, 1797, 1780, 1785, roughly. Power through the generator. 1763, 1771, 1780, 1770. So one thing for certain, the power definitely does not go up in proportion to what we take out. I have no claims that the efficiency is good of any sort, because obviously that much input for very little output as far as wattage to wattage goes. But it's not really my concern at the moment, because it could be increased a little bit, or a good margin, by winding this better. And what would happen if we get this voltage, step this voltage up high enough to feed back into the generator input, due to the fact that the current does not raise when we pull a load. If we put the output into the input to make the generator go quicker and quicker, does it create a positive feedback loop? This is what we need to find out. Join mooker.com and watch the progress.